Climate-responsive architecture is not just a trend, it is a necessity. It is a design approach that emphasizes harmony between buildings and the environment. We can create structures that are both functional and environmentally responsible. This approach prioritizes the well-being of occupants and the planet. Climate-responsive architecture aims to minimize the negative impacts of buildings on the environment. It does this by reducing energy consumption and greenhouse gas emissions. This approach emphasizes the use of renewable energy sources. It also promotes the conservation of water and other resources. The core principle of climate-responsive architecture is to work with nature, not against it. By understanding local climate patterns, we can design buildings that are naturally comfortable and energy efficient. This approach reduces reliance on artificial systems like heating, ventilation, and air conditioning. Ultimately, climate-responsive architecture is about creating a built environment that is both sustainable and livable. It is about designing spaces that are healthy, comfortable, and in tune with the natural world. Building with nature offers numerous advantages. It promotes energy efficiency, sustainability, thermal comfort, and environmental harmony. These aspects are crucial for a healthier planet and a better quality of life. Energy efficiency is a primary concern in today's world. Climate-responsive buildings consume significantly less energy. This is because they are designed to utilize natural resources for heating, cooling, and lighting. This reduces reliance on fossil fuels, leading to lower energy bills and a smaller carbon footprint. Sustainability is another key benefit. By minimizing energy use and resource consumption, climate-responsive architecture promotes sustainable living. It reduces our impact on the environment and conserves valuable resources for future generations. Thermal comfort is essential for the well-being of occupants. Climate-responsive buildings provide comfortable living and working spaces without relying heavily on artificial climate control. They achieve this by regulating temperature, humidity, and airflow naturally. Environmental harmony is at the heart of this approach. Climate-responsive architecture seeks to minimize the disruption of natural ecosystems. This leads to reduced pollution, conservation of biodiversity, and a healthier planet overall. Designing climate-responsive buildings requires a deep understanding of the local environmental context. Factors such as geographic location, topography, microclimate, and building orientation play crucial roles in shaping the design. Geographic location determines the overall climate of a region, including temperature ranges, rainfall patterns, and wind speeds. Understanding these factors is essential for selecting appropriate design strategies. For instance, buildings in hot and humid climates will require different design solutions compared to those in cold and dry regions. Topography, including elevation, slope, and surrounding landforms, also influences local climate conditions. For example, a building located on a hilltop will experience different wind patterns and solar exposure compared to one situated in a valley. Microclimate refers to the specific climatic conditions of a smaller area within a larger region. Factors like vegetations, water bodies, and built structures can create microclimates that differ significantly from the surrounding area. Understanding these microclimatic variations is crucial for optimizing building design. Building orientation is a critical aspect of climate-responsive design. The way a building is positioned relative to the sun's path can significantly impact its energy efficiency and thermal comfort. Proper orientation can maximize solar gain in the winter and minimize it in the summer, reducing the need for artificial heating and cooling. India is a land of diverse climates, ranging from the scorching deserts of Rajasthan to the snow-capped Himalayas and the humid coastal plains. Each climate zone presents unique challenges and opportunities for climate-responsive design. Hot and dry climate regions like Rajasthan experience intense heat and scarce rainfall. Design strategies here focus on minimizing heat gain and maximizing natural ventilation. This includes features like thick walls, small windows, light-colored exteriors, courtyards, and wind catchers to channel cool breezes. Humid climate coastal regions and areas like Kerala experience high humidity and heavy rainfall. Design solutions emphasize maximizing natural ventilation and reducing moisture buildup. Features like large overhangs, raised floors, and the use of breathable materials like bamboo and terracotta are common. Composite climate. The Gangetic Plains experience a composite climate with hot summers, cold winters, and moderate rainfall. Design strategies here balance the need for both heating and cooling throughout the year. This includes features like verandas, courtyards, and the use of materials with good thermal mass. Mountainous climate. The Himalayan region experiences cold temperatures, snowfall, and strong winds. Design solutions focus on maximizing solar gain, insulation, and protection from the elements. Features like south-facing windows, sloped roofs, and the use of locally available stone and wood are common.